Okay, now we're going to look at our quiz. So, I'm going to go over version A. So the questions are in the same order, just the answers are scrambled. So number 1 says, a push or a pull just describes the term force. So nobody should have missed that question. Number 2, compare to 8 kilograms of feathers, 8 kilograms of lead. This is the question that most people miss on the multiple choice. Okay? Most people miss, I don't want to say this was the question that had the greatest percentage that people missed. That's what I mean. So let's look at it. Now, the concept on this question is that mass and inertia are directly related. The greater the mass, the greater the inertia. The less mass, the less the inertia. Now, the question says, compared to 8 kilograms of feathers, 6 kilograms of feathers. Well, 6 kilograms is less than 8 kilograms. And if it has less mass, it has less inertia. So I don't know why so many people miss this question. I don't know whether maybe people got mixed up with just the English wording where it says compared to 8 kilograms of feathers, 6 kilograms, and they like reversed it in their head. But a lot of people miss this question. I'm not sure. But the concept here is mass and inertia are directly proportional. The greater the mass, the greater the inertia. The less mass, the less the inertia. That's the concept you need to know. All right, number 3, the force required to accelerate a 2-kilogram mass. So, F is equal to ma. So, 2 times 4 is 8. Should anyone have missed that? No. I mean, you learned F is equal to ma in middle school. Number 4, an object accelerates at 2.5 meters per second squared when an unbalanced force of 2 newtons. What does this unbalanced thing mean? The unbalanced thing means the forces aren't equal, and you have to have an unbalanced force in order to have an acceleration of 10 newtons. What is the mass? So again, I'm given the acceleration, I'm given the force, F is equal to ma, m is equal to F over a. So 10 divided by 2.5 is 4. Number 5, which mass would have the greatest acceleration if the same unbalanced force acted on it? Well, acceleration is F over m. So if I had the same force, remember, if I put 1 in the denominator, let's say the force was 10. 10 divided by 1 is 10. 10 divided by 2 is 5. 10 divided by 3 is 3.3. 10 divided by 4. So you could do all that, or you could just look at it and say, well, as the mass increases, this is going to decrease, because these are inversely proportional, because this is in the denominator. Number 6, as shown in the diagram below, okay, this is just Newton's third law, action-reaction. Quite a few people miss this, and I'm not quite sure why. So if the air in the balloon's going this way and the balloon goes that way, this is just an action-reaction pair. Number 7, a desk exerts a 15-Newton force on an object placed on the desk. What force does that object exert on the desk? Again, this is Newton's third law. For every action, this is an equal and opposite reaction. I don't know if you noticed this, but when I made up the quiz, I actually made the quiz up in the same order, like Newton's first law, second law, and third law, like they were actually in order. So then the last one, again, happens to do with Newton's third law. For every action, there's an equal and opposite reaction. Which statement explains why a book resting on a table is in equilibrium? The answer, the weight of the book and the table's upward force on the book are equal in magnitude but opposite in direction. All right, let's look at the FRQs. So the first FRQ says Mr. Frank is driving his 473-kilogram golf cart in the bus loop. So I wrote down the math. He starts from rest, the initial velocity is 0, and attains a speed of 15 meters per second, that's BF, in 0.59 seconds. What is the magnitude of the net force acting on the golf course? The golf cart. So the first thing I'm going to say is F is equal to ma. I have the mass. but I don't know the acceleration. So now I'm going to say, what can I do to find the acceleration? So back in Chapter 2, we learned all the equations from Chapter 2. So I'm going to have to use this. So again, we have this equation, VF is equal to VI plus AT. We have the equation VF squared is equal to VI squared plus 2AX. And we have X is equal to VIT plus 1/2 AT squared. So now I'm going to say to myself, which equation do I use? So I write down what I have. I know VI, I know VF, I have T, and I want to find A. Which equation has those 4 variables? This one. Do I still need to know these equations for this test that we're having Friday? Yes. Do you need to memorize these? Yes. Is there going to be a problem like this on the test? What do you think? So, again, this is the way systematically think about this. Did a lot of people miss this on the quiz? Yes. And there wasn't a reason for it. You can't just, physics is not one of those courses it's like, okay, we're on the next chapter. It doesn't matter anything that we've learned previously. The next question, besides doing homework problems, we did this on the lab, we did this and everything else, this is just the equation weight is mass times gravity. There were no tricks on this. So F of G is mg. And that was it. And that's the quiz.